Hello everyone, welcome back to Decode with Sahil. So today we are going to solve our next problem of the string series, palindromic substrings. So I already have uploaded the video for valid palindrome. So I highly encourage you to check that first and then come back here so that you would understand this problem better. Okay, so now let's dive right into the problem. So given a string S, okay, return the number of palindromic substrings in it. A string is a palindrome when it reads the same forward and backward. Okay. So a string would be palindrome if it is same. Like if we reverse that as well, so that will read the same, right? And a substring is a contiguous sequence of character within the string. And substring, as we know, that it should be continuous. So it is not like I can skip over an element and take a substring. It should be continuous. Okay. So we are given a string and we need to return the number of palindromic substrings in it. Number of palindromic substrings. Okay. So suppose consider this example. Example one. S is equals to ABC. Okay. So a single character would also be a palindromic substring. Why? Because if we reverse it, it would be same, right? So definition of palindrome is that if we reverse a particular string, it is same. So a single A string is also a palindromic substring. Okay. So firstly, single characters would be a palindrome. Then if I check AB, BC, but if I reverse it, it is not a palindrome. So we have three palindromic substring in this particular example. If I consider this example, A. So I have A as a palindromic substring. This A at index 1 is also a different substring. This A is a different substring. A is a different substring. This A. Okay. This A at 0 index, A at 1 index. And then A at 1 index and A at 2 index is a different substring. A at 0 and A at 2 index is not a substring because substring needs to be continuous. Got it? So now let's solve the question. What approach you can think of? So basically, like starting with the brute force, so what we can do is that we can do a nested for loop. Basically, one for loop to hold the one element, another for loop for another element. Okay. So now, and we can create a function is palindrome that will check if that particular string is palindrome or not. So I'll have two characters. One for loop will hold one starting index, another for loop will hold another starting index. I'll take a substring. I'll check, like I'll start from I equal to 0. Okay. And j also from 0. Then I'll check if that I'll pass that particular substring to a function that will check if it is a palindrome or not. If it is a palindrome, then I'll update the count that okay, I can have one palindromic substring. Then I'll update j to by one. So now I'll have another substring. So this way, I'll basically check for every particular substring and I'll pass that substring to a helper function that will return if it is a palindrome or not. But what is the problem here is what will be the complexity? We have one for loop that is holding one starting index, another for loop that is holding another ending index. Then the palindrome function is also checking if it is a palindrome or not. So we have three different things, each iterating n times. So the complexity will be n cube in that. And n cube, it is a very high complexity considering we have larger inputs. Okay. So we need to reduce the complexity. So if you have seen my video of uh, a unique palindromic substring. So in that, I have talked about an approach, expand around center. Okay, expand around center. Expand around center approach is like I can pick a center, okay, and then I can expand towards left and towards right, and I can compare the character at left and right if they are equal. That means it is a palindrome only for now, right? Because middle character is fixed. Left and right character, if they are same, that is a palindrome. Then I'll again shift the left and right pointer. And again, if they are same, that is a palindrome. If they are not, means we have got this much part that is a palindromic substring, right? So you got the basic idea behind it. So I'll use the similar approach, and then we will be able to get through the solution. So what I'll do is I'll start writing the code and I'll explain it to you step by step so that you would understand this better. Okay. So now what I'll do is I'll take a count variable 0. So this count what it will do is it will basically store how many substrings are palindrome. Okay. Now I'll start iterating over the string. Okay. So for int I equals to 0, I less than s dot length I plus plus. Okay. Now I have to count the palindrome. Okay. So I'll create a count palindrome method. I can make it count palindrome. Okay. And what I'll do is I'll pass my string and I'll pass the starting index and the ending index. Got it? So let's first write that helper method. Okay. So this will be count palindrome. So I can declare this method as a private because it is in the same class. Okay. So what I'll have a string s. Okay. I'll have a left index. I'll have a right index. Basically, to store the palindromic starting and the ending index, like until when it is a palindromic substring. Okay. Now, to count a palindrome, I need a count as well. So I initialize it to 0. Okay. Suppose. So initially, I'll have I equals to 0. Okay. Now, what I'll do is, so this is my center basically. So consider that, let's talk about this example throughout our whole program. S is equals to A. Okay. Now, I have 0. Okay. So initially, the center would be at 0 index. Now I'll go one to the left, one to the right. So initially, like I would decrement the left, increment the right. So the left index should be greater than 0 because if it is less than 0, then I will get an index error, and right should be less than the string length. Make sense? So I'll do a while condition initially that will check if left is greater than or equal to 0 and right is less than s dot length. I hope you got this idea. Now I'll also check if the character at left and character at right are same or not. Okay, let me increase. Okay, I can take this example A, B, C, B, A. Okay, so now consider this. Suppose C is my center. Suppose. Okay, and I go one left, one to the right. So this is my left, this is my right. So is it a palindrome? Is it a palindrome? Yes, it is a palindrome. So what is the condition? That both B need to be same. Both character at left and right needs to be same, right? Then only it is a palindrome. So I'll add this condition that dot char at left is equals to s dot char at right. Makes sense. So if those are equal, then it is a palindromic substring, and left is obviously greater than 0 and right is less than the string length. So what I'll do is, so this condition satisfied that it satisfies that it is a palindrome. Okay. So I'll increase the count because it is a palindrome. So I can increase the count. And I'll decrease the left, I'll increase the right because considering this example only, so I was here, suppose. Now I have to decrement left by 1 and increase right by 1 so that I can check, I can increase my range for palindrome, right? That now, is this string palindrome or not? So I have to decrease the left and increase the right. Make sense? And I'll return the count. So basically, it will give me the count, like how much palindrome were there when this particular index was my center. Okay. So basically, I would track the count, update the count here only. All right. Now, this is my odd length of string. Okay. Like if my whole string length is odd, then I would have one center. What if my string would be this? A, B, C, C, B, A. This is also palindrome, but this is even length. So if I take this C as a center, then I would compare this C and this B, which will always be unequal. If I take this C as a center, this will take compare. So I would get my answer as 0 with this approach. So considering this, like if I have even length of string, so what I have to do is I have to take two centers in this so that I have these two centers and I can compare those two centers and I can shift those two centers back so that I can count it accurately. So considering this, I have to call this function two times, considering one center at a time, considering two center at a time, whichever condition is satisfied and whichever produces more count. Okay. So what I'll do is I'll call the count palindrome method again. I'll pass the string. Okay. I'll pass two indices now, I and I plus one, because now I want two centers in this. Okay. And it will also return me, bring me a count. So I'll update it to the original count which we'll have. Okay. So here we are considering even length, and here we are considering odd length. Got it? Now, now we'll get the count, we'll get the updated count. We'll consider both the cases, odd length, even length, and whichever returns the better count, it will get updated. And obviously, after this loop is done, I'll return the count. So that will return me the updated count. Okay. So now I'll quickly run this program. If it runs successfully, I'll try run the code for you so that you would understand it better. Okay. So it's accepted. I'll submit it. All right. So it's working fine. Okay. And let's do a time complexity analysis. So what is happening is that this count palindrome function is taking n times, because if I'm here, suppose if I'm at this C, so it would go to the left and to the right. So in the worst case, it would go, or if this is my center, so it will go here. So basically, in the worst case, it will go n times. And this is also going n times. And this is called inside this. So it has a time complexity of n square, big of n square. Okay. So, and the space complexity is big of one only because we haven't taken any other variable. Okay. We have just taken some integer variables, which doesn't add to the complexity. Okay. So now I'll try run the code for you. I'll take a simple example, A. Okay. Let's do it. What I'll do is I'll start with each character as a center. Okay. So now center at index 0. Okay. So odd, considering odd. Okay. So now considering odd, this is S, it is 0. So now it goes to this function, count is 0, left is greater than 0, right is less. S dot caret left means A is equal to A. So I'll increase the count. So in this case, the string that is considered is S equals to A, right? A, only A. So it is a palindrome, count gets increased. Okay. Now again it goes into the condition. Now left is now -1. So it goes out of this. It returns the count. Okay. Now it comes here, 0, 1. So now we are counting for even length. So now the string is AA. Now it will start checking in here. Again, it all the condition gets true. Count gets incremented by 1. So the original count is now 2, right? Now, since this is done, so now I will be incremented to 1. Now, S, now 1, 1 is passed. So again, the string becomes A because S of 1 is A, right? Now again, this condition works for only for the one time because the index would go out and it again it get incremented by 1. Then it goes to even condition, again incremented by 1, count gets 4. Similarly for last index as well, it works for, so the count would be 6 later on, right? So now this approach works fine and it is one of the best solution that we could think of in this. There's another solution for dynamic programming that could work in this case, that could generate a better time complexity. But when I'll start the dynamic programming series, I'll try to incorporate it there. Until then, I think I'm done for the string series, and I'll start another data structure series by tomorrow. And I'll see you there. I hope you got the concept. Like, don't worry if you're not understanding anything or if you're not able to write the code. Just try to understand the logic behind it. Like, why we are doing this, why we are picking up the sentence, what are we trying to do. If you are not able to code it, that is completely fine because you don't need to worry about the code. You have to build your logic. Like it will take around 50 problems to build your logic, and once you are onto it, you can do any code. Okay, trust me. Like it's a easy process. Writing code is not that complicated. Even if in interviews, if you're able to explain your thought process, that is also fine in most of the cases. Like you have to write the code, but you can explain the algorithm. So you don't have to worry. Just stick with your approach, get your basics right, and you'll be fine. Okay. So I hope you like this video. Make sure to subscribe, and I'll see you in the next video.